I'm Mike James, and in this tutorial I'm going to show you how to solve a system of linear equations using the calculator. In this example we're given a function fx equals ax cubed plus bx squared plus c, where a, b, c are real numbers. The graph of f passes through the point 2, 9, and also the graph of f has a local minimum at 1, 4. We've got to find the values of a, b and c. So we have a cubic function, and we're given some information and we need to find a, b and c. So let's use this first sentence. The graph of f passes through the point 2, 9. This means that when x is 2, y is 9. Now remember, f of x is the same as y. So all we need to do in this first part is rewrite the equation. Y equals ax cubed plus bx squared plus c. Replace y by 9 and x by 2, and we can form an equation in a, b and c. So if y is 9 equals a times 2 cubed plus b times 2 squared plus c, and that simplifies to 8a plus 4b plus c equals 9. We can also use this information. The graph of f has a local minimum at x is 1, y is 4. Now a local minimum will occur when the first derivative f dash x is 0. It's actually a turning point. So I'm going to rewrite this equation, fx equals ax cubed plus bx squared plus c, and differentiate it. F dash x equals 3ax squared plus 2bx, and if you differentiate c you get 0 because it's a constant. Now remember, for turning point, that is the minimum point, the first derivative is 0, so we replace f dash x by 0. We also know at the turning point x is 1, so we replace x by 1. And we get 0 equals 3a times 1 squared plus 2b times 1, which gives us this equation, 3a plus 2b equals 0. So we have two equations, but we need a third equation because there are three unknowns. So we can use this same sentence again because it gives us some extra information. It also tells us, because there's a turning point at 1, 4, that the graph must of course pass through this point as well. So we can substitute x is 1, y is 4 into the original equation to form a third equation. And that's what I've done here. So this is very similar to the first part. So if you substitute x is 1, y is 4 into this first equation, you'll get a plus b plus c equals 4. So we have three equations now in a, b and c, which gives us enough information to solve for a, b and c. We have three equations and three unknowns. Now you could do it manually, but I'm going to use a calculator. So I'm going to go into the calculator, and one way of doing it is to make sure you're in calculate view and to hit menu and to go down to algebra, hit enter, and go down to solve system of equations, hit enter, and choose solve system of linear equations because they are linear, that is straight line equations. Now if you hit enter you get a pop-up box. Now the number of equations in my case is going to be 3, not 2, so change the 2 to the 3, and I'm going to tab. Now I get x comma y comma z are the variables. Well, my variables are a, b and c, as you can see down here, so I'm going to re-enter that as a comma b comma c. And tab to OK, and it's important, by the way, to put the commas in, and hit enter. Now we get a template, and as you'd probably guess, we just enter these equations into the template. Now you can see them down here, so I'm going to put the first one in, 8a plus 4b plus c equals 9. So I'm going to now enter the second equation, 3a plus 2b equals 0. And the third equation, a plus b plus c equals 4. Okay, I'm going to hit enter now. And there it is. X is 2, well not X, A is 2, B is minus 3, and C is 5. So there's our solution. A is 2, B is minus 3, C is 5. You can always check this. They're quite easy to check because they're whole numbers. If you substitute A is 2 into the first equation, and B is minus 3 and C is 5, you should get 9. So 8 times 2 is 16, minus 12, which is 4, plus 5 gives 9. And you can check the second and third equations. So there's our solution set. We've solved the problem. But I'm going to show you an alternative way of doing this. We can also solve these simultaneous equations using matrices. So this is an alternative way of solving that system of simultaneous equations. There are the three equations again. This time you can write them as a matrix equation. And I simply take the coefficients of A, B and C, which is 8, 4, 1 and 3, 2. Now there's no C in the second equation, so it's 0. And the coefficients of the third equation, 1, 1 and 1, and I form a 3 by 3 matrix multiplied by the variables, which are A, B and C, equals 9, 0, 4 on the right hand side. Now to find the values of A, B and C, I simply put that A, B and C equal to, and I multiply or pre-multiply the 904 by the inverse of this 3 by 3 matrix on the left. So to use a calculator to do that, I can find the inverse quite easily. So I'm going to go back to the calculator and see if I can work out the values of A, B and C using this approach. So I need to enter this matrix and inverse it. So to do this, I'm going to hit the catalog button, and the 3 by 3 matrix is already selected, so I'll hit enter, go to OK. There's my template. So I'm going to enter the numbers. So I've got 8, 4, 1, 3, 2, 0, 1, 1, 1. Now it's important, once you've entered these numbers, I'm just copying them from here, that you hit the right arrow button so that the pointer is outside the matrix now. And I'm going to raise this matrix to -1, so I hit the raise button, which is this button here, to the power of -1. That will give me the inverse. Now I've got to hit the right arrow button so that the pointer is at this position. And I'm going to multiply that, so I hit the multiplication sign, gives me the dot by this column matrix, 904. So I'm going to go back into the catalog and I'm going to use the same template. Now the number of rows is 3, but the number of columns I'm going to change to 1 and tab down to OK, hit enter. So I'm now going to enter 904 and hit enter, and you can just see, I'll bring this into view, you can see the result there, 2 minus 3, 5. Expect a column matrix as an answer because it's a 3 by 3 multiplied by a 3 by 1. So A is 2, B is -3, C is 5, as we had in the previous case. And there's the answer there. So that's an alternative way of solving the system of linear equations using matrices. I hope you've enjoyed this video.